Good morning, everybody. My name is Jalen Carter. I'm the Community Program Manager at the Tulane Innovation Institute, and it is my pleasure to welcome you back for a new year. Happy New Year, everyone, of entrepreneurial education from the Tulane Innovation Institute. We've got a webinar for you today on AI best uses for Startup Primer and Tulane projects, and I'm going to introduce our wonderful speakers for today. Dr. Aaron Kulata is an associate professor of computer science at Tulane University. His research investigates computational methods to learn about human behavior from online social networks, combining machine learning, natural language processing, and social network analysis. Examples include tracking diseases, measuring effectiveness of public health campaigns, informing crisis response, preventing online harassment, detecting deceptive marketing, and identifying unsafe products. He obtained his PhD in computer science from the University of Massachusetts Amherst in 2008, was a Microsoft Live Labs Fellow, a NAR Prize finalist, and a recipient of Best Paper Awards at AAAI and CSCW. His interdisciplinary research is supported by several NSF-funded collaborations with researchers in public health, political science, marketing, and emergency management. Dr. Nicholas Mattei is an associate professor of computer science at Tulane University and co-director of the Tulane Center for Community Engaged AI in New Orleans, Louisiana. His research lies at the intersection of artificial intelligence and machine learning with applications in data science, economics, decision-making, and psychology. His projects leverage theory, data, and experiments to create novel algorithms, mechanisms, and systems that enable and support individual and group decision-making. He has published over 100 academic articles in top conferences and journals, received multiple grants from sources including Google, IBM, and the National Science Foundation, including a 2024 NSF Career Award, and is co-author of the new book, Computing and Technology Ethics, Engaging Through Science Fiction from MIT Press. Before joining Tulane, he was a research staff member at IBM Research, TJ Watson Research Laboratory in New York, United States, a senior researcher at Data61, CSIRO, NICTA, and conjoint senior lecturer at UNSW Sydney in Australia. And before that was an aerospace technology engineer at NASA Ames Research in Mountain View, California. He completed his PhD in 2012 at the University of Kentucky. Thank you both so much for being here, and the floor is yours.
Awesome. Thanks, Jalen. Thanks everybody for having us here. This is it was a long, I got to cut that intro down. So yeah, we're going to talk a little bit today about what we're doing here at Tulane, a little bit of background on artificial intelligence. The way that we're going to sort of break this up is I'll talk for about 20 minutes, about sort of broad background of AI and, how we got where we are right now, and sort of set some scene that try to convince you all it's more than just a language box that we can throw at things. And then Aaron's going to take over and he's going to talk a bit more about some specific use cases we have with various partners around town as part of our efforts at the Center for Community Engaged AI. And also, as part of our efforts with Tulane Innovation, we have our AI Innovation Fellows, which we're working with the LePage Center for Entrepreneurship as well to try to bring more AI tech development, easier access through both the Innovation Institute's programs for the community and as well sort of internally with Tulane. So if folks have questions about that, please do reach out to me or ask questions. So as we go, if folks want to ask questions, just there's only about 14, 15 of us here. So if you want to just unmute yourselves and yell at me, that's what my students do. And so, or you can put your hand up and we can do that, but we'll make sure we save some time for questions at the end. So I'm going to give kind of a broad overview of AI and how we got here and what we try to disambiguate a little bit, what we mean when we talk about AI and leverage a little bit of, my work, both having done tech consulting, AI consulting type stuff for the last almost 20 years, even back before we could call it AI consulting. NICTA and Data61 were both government-funded research labs where we did optimization consulting, which basically meant we used machine learning to help out with strategically important businesses for Australia. And I also have this book on undergraduate education about tech application. And I think one of the big things that I do in my teaching and my work, and then also as in our work at the Center for Community Engaged AI, is really try to think more holistically and more critically about how we apply these technologies. Because I mean, sure, you can throw everything in a language model, especially now, they're making it very easy for you to throw absolutely everything you can. But I think without a firm grounding of what these things are good at, especially sort of the modern products that are being pushed across a large range of commercial partners, as you may have seen out there, without really understanding what they're doing, it becomes ripe for kind of misuse. And as someone, I think Aaron and myself, who've been around this for quite some time, this is sort of what it feels like on a regular basis to me, which is everything was crypto up until about a couple of years ago, and now everything's AI, and it's a very interesting space to be in. Most folks, when they talk about AI now, and my joke for this is that I've been married to my wife for quite some time, longer than you might think. And my mother-in-law never really asked me much about what I did in my day-to-day life, even as we moved around and I worked for all these companies, until one of her friends sent her ChatGPT. Sorry, completely taken aback by what it could do. And so it's generating these pictures. I ask it to write my papers all the time. I also ask it to write my talks. These days it's getting real good. This sycophantic part of it, I'm really happy that it likes to talk about the visionary work of Nicholas Mattei. This is the difference between, I think, ChatGPT back in 2023 and sort of this is Gemini, I think, last week. I often ask it to generate pictures. This is asking it to generate a picture of me. I have no idea what's going on here. Outside, it got tall white guy, right? I'm into that. I asked it to do it the other week, and it's kind of amazing, right? So here, like this background here, this is just, I don't know, some gobbledygook it pulled off, who knows where it came from. This is actually, I'm almost positive, a slide that I have given. It looks exactly like my standard template. It's getting pretty good at this thing. The only big difference here is it's got a face now, but this dude has facial hair, and I haven't shaved in a week, so it's just, that's my lot in life. In terms of these logic errors, again, this is back on ChatGPT 1. You could kind of fool it into all kinds of different things. There was this fun website where people kept track of just basic logical fallacies that would fall into, because it is a language model, and it still kind of does sort of goofy stuff at times when you do bait it. At least for me and my experience, especially with my students, this is kind of what ChatGPT gets used for. The amount of AI slop email that I have to kind of wade through on a daily basis. I'm actually starting to tell my students, I don't want to see the extra stuff. Just give me like five-word emails. I don't want to see the rest of this crap. I'm tired of reading it. But this seems to be what folks are using it for, and I find this like really disappointing, because it's an incredibly powerful technology that can let us do all sorts of fun stuff, but it is very limited. I'm not a big fan of everyone trying to use it for absolutely everything. It's very good at certain things, and hopefully, we're going to talk briefly about that in this part. And I think used correctly and thoughtfully, I think it's got a lot of applications, in the startup space, and it can really ease the transition for a lot of technical products. My lens for a lot of this is this book that I help write, which is all about using technology sort of, in a thoughtful way. It's technically an undergraduate ethics textbook, which is required for computer science students and most professional engineers. But we use science fiction to try to hook the kids. It's a lot of fun. But I basically spent most of COVID and a couple of years before that being yelled at by like people that are actual moral philosophers. And so I've got a somewhat different thought about how we go about these things. And I think it's been kind of interesting to be in this space over the years, because back, 10, 15, 20 years ago, this is what most people thought about AI. What I thought about what was ethical AI and what was unethical AI, what was good, what was bad. There's going to be these robots. They're either going to help us or they're going to try to kill us all. I personally have to say that the best part of all of this is that, they stopped putting my picture next to the Terminator every time I give a talk. I'm very excited about that. But in reality, what AI is doing and what AI has been doing for the last 50 plus years is helping us in the lab, right? Helping us analyze large amounts of data. It's helping run our cars. Multiple systems in your car are run through predictive Kalman filters, other sort of models that are helping control it. It's running airplanes. It's been doing that since the 1980s through autopilots and other various things. Perhaps most commonly, you have your pocket supercomputer over there. All kinds of image processing, AI backend models to help you take nice photos, even when the light is low, all kinds of things like that. And my personal favorite, helping me find pictures of my cats. That's what it's really good at these days. Which, when I ask my students, I'm like, hey, is this AI? And they're like, no, that's just what your phone does. And I think this kind of highlights the perennial problem in AI. This idea of being able to match faces. There are DARPA programs going back to the 1950s on this. There's millions of publications in this space. And now it's just a thing our phone does. And so I think it's been interesting to see how quickly some things that were cutting edge AI have just become sort of what we do now. And I think really kind of take for granted in a lot of ways. And even more than that, the sort of more traditional stuff is everywhere, right? It's everything you buy, everything you search, everything you listen to, everything you watch, everything you read, everybody you date, everywhere you travel, what you eat, what your endpoints are, and the news that you read, right? So every single one of these websites has an AI layer that is pushing you particular content, and it's pushing you particular things that it thinks that you're going to click on. And this, more or less mediates your entire interaction with the world. I don't know about everybody, but this is a good part of my day is probably using one or more of these services. And I think that helps us think hopefully about these questions in a little bit of a deeper sense. And I don't want to belabor this point, but one of the things that I try to make sure I kind of get my students to really think about is, it's not about, is a particular technology good or bad? It's the broader ecosystem that we embed that technology within, right? So-called socio-technical system. If you just think about AI as a tool, then you can sort of ask very impoverished questions about what it's doing or what it may do. And I think broadly that conversation is starting to catch on, but I still have to hammer home. It's like, don't ask me if AI is bad. We can talk about a whole bunch of stuff around that. And one of the things I like to do, and this is an example stolen from Sheila Jasanoff, who's a great person who talks about the ethics of invention and innovation, is this idea of a stoplight, right? And a longer form, I kind of go on and on about this, but basically a stoplight is a piece of AI technology, right? It senses its environment and it effectuates change on the world through an actuator. This is a classical definition of what is AI. We've had them for a long time, but at the end of the day, it's just a colored light on a pole, right? It doesn't do anything. What does the work, what we see as the work of a stoplight is the police, is social convention, is all kinds of other things that we've built around what this technology has enabled, which is us to drive in cars very, very fast in very large cities. More to the point, I love the fact that if you go back and look at the history of a stoplight, stoplights are like the original, not the original, but a very early piece of AI technology. And I think it helps contextualize some of our arguments. So when stoplights were rolled out, in the late 1800s, early 1900s, predominantly in Cleveland and New York, there was a whole bunch of stuff. You go read some newspaper articles from there. They're very fun. We have some excerpts in the book. People complaining that this piece of technology is getting between them and their neighbors because you used to pull up to stop signs or uncontrolled intersections and wave at each other. The stoplight is single-handedly ruining society. It's eliminating jobs for folks that may have traditionally waved traffic, things like that. It's creating road rage. It's alienating us from each other. And the first automatic stoplight installed in the United States, which was installed in New York, actually blew up and killed its operator, right? Kind of tragically. So here we have a piece of AI technology that has been alienating us from one another, eliminating jobs, and coming out to kill us, and increasing pollution and all kinds of other stuff. So I find it, kind of really funny to see that a lot of these sort of technology tech conversations have been going on for quite some time. And the key question I ask my students, all the time is really don't ask me if a technology is good or bad. Ask me what's at stake. What's at stake by your application or your deployment of that technology? And my classic example here is, I'm old enough because I'm of the right generation to remember when Facebook had automatic image recognition, took it out, put it back in, and then took it out again. So it's been in and out about 3 times. And it used to automatically tag photos of you. My wife, very much non-Facebook haver, it always used to confuse her with my mother-in-law, who's a very chronic Facebook user. And, is that the limit of what bad can go wrong? What's at stake if you're mistagged in a Facebook photo? Not much, kind of, unless maybe you're someplace like a concert you're not supposed to be at. I guess there's always some bad things that can happen, but it's somewhat limited. But this is just general facial recognition technology, right? This is an AI algorithm as far as I'm going to use it. It's the same thing that is on the back of every police car in the city of New Orleans that drives around and scans all your license plate. It charges you tolls when you go over the bridge. it's doing automatic plate reading. This is common in Texas, Florida, all through the South. There's a few more things at stake here, right? Like you can get in a little bit of trouble. But it's the same fundamental technology, right? It's the same image recognition technology that we're going to use, installed in a different place. And more to the point, both in New Orleans and across many cities in the United States, this is what it predominantly gets used for these days, right? Is facial tracking across multiple cameras, across multiple parts of the city, right? And this has been deployed in various ways that you may or may not have issues with. And I think you can have a robust conversation around that. And so this is why, I really want to underscore that, like, it's not about whether or not the technology, the algorithm is bad, is ethical. It's what we do with it, and it's where we deploy it, and it's the systems that we build around it. But hey, enough of my diatribe. What the heck is AI? what do we even mean? You're sitting here talking about AI for the last 12 minutes, and you haven't given me a definition yet. And for those who maybe don't know, this goes back to the 1950s, where Alan Turing, which is more commonly looks like this guy if you watch movies, asked this very simple. He's asked this question. Can machines think? And Alan is somewhat famous at this point. This is post-war period. Everything that happens in that movie has already happened. He's already broken the German Enigma code, all this other stuff, and he kind of dodges this. Talks about he wants to dodge this question, and he starts off in this very mathematician-y way by saying, okay, well, I'm going to consider the question, can machines think? But I'm not actually going to answer that question. I'm going to replace it by this other question that's expressed in unambiguous words. And what he sort of proposes is this riff on what's called this thing he calls the imitation game, which is a riff on some other sort of games in the Victorian era about having an interrogator that's going to ask both a computer and, brief aside, a man pretending to be a woman, which is very strange, questions, and try to figure out which one's the computer and which one is the man trying to pretend to be a woman. It's very. By the way, Alan Turing was gay. He was chemically castrated by the British government, and then he killed himself. So it's very tragic. There's a whole literature on the a whole other side of the sexual dynamics of all this, but it's kind of interesting. But the reason I always bring this up is, and I ask my students all the time, what is ChatGPT doing fundamentally? What did ChatGPT 2.5 try to do? It's to win this game. It's to say things to you in a way that makes you think it's human. And the history of this whole thing, I think, is very important to understand, because what these chatbots were, what they initially were, what they were in the 1970s, what they were in the 80s, was someone trying to meet this definition of what AI is, which is the ability to passively convince another person that it's a human, or that it responds like a human. And I think if we lose sight of that fundamental part of this, you start trying to throw these chatbots in places where maybe you don't want it to be human. Honestly, when I ask Google for directions, I don't want it to be human. I grew up pre-maps, and it'd be like, oh, drive down past the Bacon's, which is a store that doesn't exist anymore, and take a right. I don't want that. I want a map. And so there's various technologies in the space, and some are better suited for some of the tasks that we're going to do rather than others. And so there's a whole argument over what we're trying to do. This goes back to the 1950s, AI, the whole idea. I think very funny here, very, very academic, I always have to point out. This is Marvin Minsky, or I'm sorry, this is John McCarthy, who's very famous, sort of coins the term, proposes a 2-month, 10-man study, and we're going to make significant advances in AI if we have those people work on it for a summer. It's the height of academic fundraising, and also, sometimes startup fundraising is, we're going to solve AI in a summer with 10 people. Don't worry. And this was in 1956, so it's always very funny. So why is the Turing test kind of this enduring legacy, within computer science, and seen as kind of this ultimate goal? Well, it's thought for a long time that in order to pass this, you have to do all of the sort of the mental, you have to do the things that people kind of do, right? Because you got to be able to process natural language, you have to be able to remember things, you have to reason, you have to adapt to new conversations, right? And so the reason why this is so used is because it doesn't encompass a lot of the tasks that we want our computers to do, the tasks that we want our computers to do that appear smart. And when we teach AI, this is kind of the model that we use, right? We have an agent, what we're going to call an agent, that's going to interact with this environment through some set of sensors. And it's going to affect change in its environment through some set of actuators. For ChatGPT, that's a chat box, right? It's going to sense what you're trying to say. It might also sense the internet. It might bring things in like that. And it's going to respond to you within the chat box, or it's going to generate images and things like that. But this, what we call agent-based setup, is, goes back to the late 90s, to be perfectly honest, but now agents are a whole other thing. But the agent idea is still the same, but the idea is that we're trying to make these smart systems. And now, a lot of times these agents are just going to be one LLM, but historically it's not necessarily always been that way. There's a bunch of slides. I think these are all going to be made available. This is a whole timeline that I've stolen from people, but what you kind of see between the 1940s and the 2010s is a lot of what we call good old-fashioned AI, a lot of booms and busts in the system around funding and things like that. You start to see a little bit of resurgence at the end of the 90s, beginning of the 2000s, which is when I sort of started doing a lot of this stuff. And then really since 2010, you've seen a pretty straight line between advances in compute, large advances in compute, and a lot of these applications of these models to very large data sets at very large scale. And there's a little bit of algorithmic stuff that's happened, right? There's very important things like the transformer architecture that have come out in the last 15, 20 years. And a lot of it is just, we've got a much bigger computers, like orders of magnitude bigger computers, which just makes kind of things interesting. So fundamentally, what are these AI models? What is Google and Microsoft and everybody trying to sell you? They're trying to fundamentally sell you what we call a text-to-text system. So what we're going to do is we're going to scrape lots of text from the internet. We're going to use this as our training data. We're going to create a giant statistical model that relates how words appear and how those words appear to other words. And then we're going to give it a prompt. We're going to say, okay, well, give me the Gettysburg Address. And we hope that this thing sort of pulls out of its weird memory 7 years ago, blah, blah, blah. And we'll get a little bit more into how this works here in a second, but this is the basic idea, right? These are what we call text-to-text models. They don't typically have a complex or robust model of the world that's supposedly, and this is the thing Aaron and I fight about all the time, because I'm more of what we call a good old-fashioned AI guy. Aaron's one of these statistics, take care of everything guys, and this is the basis of our friendship, to be perfectly honest. This is what happens when you're a professor. So this represents, I think, to some people, and you see this sold kind of as in the startup space a lot as, kind of the third major paradigm or the third paradigm of computing. You've had this history of traditional programming where we have a very deterministic, we had this machine learning period where we're doing data. And I don't really buy this. I stole this slide from somebody else, that, we're going to have these general frontier models that do everything. And I think I'm not just alone in this, like Yann LeCun just left Meta basically saying the same thing, that only having these sort of just statistical relational models are maybe not going to deliver exactly what we hope for. So I'm going to take the last couple minutes here and try to convince you, or give you just the background on how these things work and convince you that most people understand or have done in high school a lot of the math that's necessary to understand what's going on. And so we're kind of here. This is our fun, like third wave, what we call third wave AI. It just keeps going up. It's been surprising even to me. These are our major players. So what does an LLM do? Well, fundamentally, it's a probability distribution over sequences of words, right? We want that the probability, that when we try to translate "she sees a flying bat" into Spanish, we end up with the correct, bat form here as opposed to a baseball bat. And mathematically, what this is doing is it's saying, what is the probability of the next word given the history of words that I've generated so far? Oftentimes you'll hear this called the context or the context window. This will be some fixed sized function of the history. And what I'm going to do is I'm going to run this, in a recurrent manner. And I'm going to basically feed all the words I have so far, which is the prompt and all that sort of stuff. There's some meta prompting going on in the background into the system, and I'm going to spit out the next word. And so how this actually works, even though it's kind of hidden from you, is, you feed it. The best thing about AI is the ability to create worlds that are both exciting, right? So we're just going to fundamentally rerun this with every word as we go forward, picking sort of the most probable token. And this idea, and this is a slide I stole from Aaron, is great because this goes back to this guy named Markov, who's trying to understand how poetry is formed, right? This is in the early 1900s. And so this idea of trying to put probability on sentences is a very old idea. It's just that we're doing it with these neural networks at a scale that Markov's over there like doing this by hand, right? And now we're doing this with basically all of the text on the internet. And what is this? What does ChatGPT stand for? The name's in the title. It's this generative, right? Produces text, pre-trained, right? Because it's trained on the background of all the text in the internet, and a transformer, which is this idea of it's going to capture these dependencies between things. And fundamentally, and I'm going to say two more things, and I'm going to quit. All of this is a machine learning model. This is machine learning at scale. And what we do in machine learning is we're really trying to get the computer to do well by exposing it to more examples of what it's supposed to do. And this is what's called inductive learning. For those of you who maybe remember, inductive learning is this idea. Deduction is, what Sherlock Holmes does. It takes a definition and it goes down and says, oh, like these are boxes and these aren't boxes. Inductive learning, by contrast, and this is what all machine learning kind of builds from, is we're going to give you, I lost all my stuff. We're going to give you all of these examples, right? All of the words that come next, and then we're going to let you learn generalizations from that. And I think it gets a little confusing when it's words, because quite frankly, all of us have done this when it comes to data. And in data, what we're going to do, like the way that you can think about this, is let's say we want to do a very simple task, right? We want to predict someone's height based off their shoe size. And we've all done this, and we don't think of this as machine learning, but we can go out there and we can collect a bunch of data about, what are people's height and shoe size. And then if we have some out of sample piece of data, right? We have somebody with a shoe size of 10 and we want to guess their height. What do? This is standard high school curriculum math. Well, we draw this line of best fit. This is now I can use as a predictive model to predict what the next person who shows up, what their shoe size is going to be. What we do in ChatGPT is we do this with terabytes of data. This is what we call a two-parameter model, right? Y equals mx plus b. ChatGPT has what? I think it's a billion. We see those little 7B, 10B. That's the number of free parameters within those models. But fundamentally, what it's doing is it's making a prediction over the next set of tokens that we're going to use. And the other part that I'm going to kind of say, and I think this is kind of where things get a bit more interesting before I turn it over to Aaron, is that when this first started out, when we had ChatGPTs, let's say 2.5 or whatever, it was just a language model. Whatever you fed it, it went to the language model and it spat stuff out, right? Because it's just a word-to-word model. We're just going to say things. These models get better. These models then are using a whole bunch of stuff in the back end. There's all these like reprompting. There's all this like web searching that's going on. Then we get a whole bunch of models, and then they're better at certain things. And now we're up to the point where basically you can take a picture of something on my whiteboard and you can ask it for an answer, right? And you don't know a lot of us don't know. And quite frankly, that's kind of the point. What exactly they're doing in the background, how much they're reprocessing that data, how much they're kicking it to other various things. And so these, honestly, when you go to ChatGPT, you're not interacting with just a language model anymore. You're interacting with a fully fledged kind of AI system that's trying to possibly simultaneously search the web. It's reading your code base. It's pointing at documents that you have. Like it's doing a full AI system, or what we would have considered in a full AI system stack, 10, 15 years ago. And that's really what a lot of the stuff that we're doing here is all about in the Center for Community Engaged AI, is trying to, maybe we'll use a language model, maybe we'll do some other bespoke things, but like a lot of times folks have very particular prediction problems. They have very particular types of things they're trying to do that a broad general language model is maybe not so good at. And I think I'm going to turn it over to Aaron, and Aaron's going to talk a little bit more about some of the stuff that we're doing here at Tulane and the ways that we deploy these technologies, within the community to kind of do cool stuff.
Hey, thanks, Nick. Yeah, while I bring up the slides, I wonder if maybe now's a good time if anybody has any questions on that first half of the talk. You can just go ahead and unmute me. Share. And if not, I'll just soldier on. Well, hi, everybody. Thanks for being here. So, Nick kind of gave a broad overview of what AI is and where we've come in the past 50 years on AI. I want to talk a little bit about some of our applications. Jordan, did you have something you wanted to say? I see you unmuted.
Oh, I'm sorry. I didn't even know I unmuted.
That's okay. Both Nick and I have spent some time in industry, and while of course we're doing research, academic research, we also do a lot of applied projects. And so I think some of our experience here might be relevant to those of you, looking to do startups or work in innovation space around AI. I guess the first most obvious thing is that, AI has greatly reduced the barrier of entry to like developing computational applications, right? Think about vibe coding, obviously. But just generally the ability to use these AI models to make applications that are way more intelligent than kind of ever before, right? And this is as hard as it will ever be to make these apps. It'll only get easier. So what I want to do is just kind of show you a few of the different applications we've been working on, kind of in partnership with local nonprofits and governments around here, as a way to give you a sense of the different types of projects that might be relevant in the startup space. Before I do that, I do want to plug. I just put in the chat. So I just started a new course this semester called Intro to AI Engineering, and kind of the motivation was, I'm seeing, because the bar is lowered as far as building these kind of systems, you can now, it's easier than ever to get an MVP of like, you have your idea, you can ideate on it and get something that actually kind of works very quickly with a lot of these different low code, no code tools. And two pieces of misinformation I want to push back against. One, that doesn't mean we don't need computer scientists, because what that does mean is that we've now increased the kind of supply of computational systems, which we need more engineers who are able to make sure those things actually work in practice, right? And so that's this course I just put in the chat is really focused on, okay, you've got a system that uses AI, now what, right? And I think that's really important, going from MVP to like functioning system, all those issues of security, privacy, all that kind of stuff, hardening the system is going to be critical. So let me just jump in here for a little bit. So part of the motivation of this Center for Community Engaged AI is to try to figure out how we can kind of harness some of these resources we have in academia to go and try to solve problems out in the community using AI. And so we have this, because Nick mentioned this like socio-technical system kind of thing, right? So one thing I want to emphasize is, of course, these are not just technology problems. Even if you're a startup, it's not a technology solution, right? It's technology plus the business context in which it's appearing, right? So, for the center, we felt it was important to engage folks from kind of very different perspectives to understand how do they go about problem solving in their domains. And that's why we have folks like from sociology, econ, and public health here. And one kind of like design principle we kind of focus on is called participatory design. In a sense, it's not very revolutionary, and it's just kind of standard good software engineering practice, which is if you're going to design a system that's going to affect people, then kind of step one is figuring out who are all the people that are going to be affected by it and get them in the same room to understand kind of what their real needs are and to involve them in the design process from zero, to the end. And when you think about designing a new solution or starting a new company, right, that customer discovery period, right, I think is critical to that. But that shouldn't stop at that discovery point, right? I think especially with AI, the ability to quickly iterate on things means that you want to have a constant feedback loop from kind of as many different peoples that'll be affected by the system. So in our work, the way we've kind of set this up is this sort of pipeline of projects where, step one, we kind of organize just outreach events to kind of listen to the way people are thinking about how AI could be used or could improve kind of what they're doing. And we've held many of these kind of community events over the years. The second thing, and this is obviously something as academics we can do, is that we have these senior capstone projects, right, where we have a lot of undergrads who can kind of do self-led projects. And we find these really helpful to get that initial relationship building with different clients, different partners who would be using this. A lot of folks, if you think about kind of, going into a new domain or something like that, and Nick and I will agree on this, the first thing you always find is that the data isn't what you thought it was, right? And so when we talk about AI systems and let's go build an AI solution, often 80% of that is let's figure out what the data situation is and what do we need to do to bring that data infrastructure up to speed so that AI can actually be most helpful, right? And that's often what we end up doing in this kind of first phases of these projects. And in the third phase, again, as academics, we figure out, okay, well, this, for this particular problem, we need to bring in people with these different types of expertise so we can really have kind of a holistic approach to the problem. So I'll briefly today mention 3 examples of the sorts of projects we work on through this center. And then 3 different kind of spaces, one in kind of criminal justice space, the second in more civic transparency, and then the third in the health space. So the first one, our partner here is Court Watch NOLA. It's a great organization that does what their name suggests. They train volunteers to sit in criminal court every day and observe what goes on. They fill out kind of data sheets that describes what happens. And their job is to kind of, just provide transparency, right? So, did the judge show up on time today, right? Was the defendant asked all the questions the defendant should have been asked? Just procedurally making sure things are going kind of as they should. There's a lot of data here around the court system, obviously. And part of our goal here is to be able to provide data or AI tools that help many different types of stakeholders, whether it's victims, defendants, attorneys, nonprofits, more easily understand, query, and oversee cases in criminal court. And so I mentioned that first piece is like, well, where's the data, right? And so for this project, we kind of looked at 3 different types of data. One, the volunteer court observations. So these are, again, the volunteers that are recording in, SurveyMonkey forms, everything they observe. 2, the court dockets. So these are kind of the official kind of notes taken, brief notes that kind of indicate what happened at each hearing. And then 3rd, more intermittently, we get these public records requests that are different kind of tranches of data. And so kind of the first phase of this project was kind of simple data dashboarding things. Like, let's just get all the data in one place so that I can actually search it as you would normal data sets, so that we can actually look at things like how do bond amounts vary by race, sex, or crime, and that kind of thing. So just really getting some transparency into this sort of thing so that you can do things like, okay, let's just track trends over time, right? So no AI here, just getting data in the right place. But often that adds a lot of value to organizations, even before you get to the fancy AI stuff. And then kind of the second phase is trying to figure out, okay, now that we've got all this data in one place, where does AI fit in, right? How can AI help us understand what's going on in court a little bit better? So, sometimes when people hear AI and criminal justice in the same sentence, they think of, a lot of things like risk scores, right? So people have used this for a long time to kind of assess the recidivism risk of defendants and that kind of thing. That's not our goal here. We're not trying to replace kind of the human judgment that is so critical in this domain, but rather we're using it more as a way to kind of look back on the trajectory of the court system to see what impact different variables have on different outcomes. And just like Nick was talking about, kind of these language models predicting the next word in a sentence given volumes of data. These are sometimes called foundational models. And you could do a similar sort of thing kind of for any time series data or any data for that matter. And so that's one thing we've been working on is building these models that can predict kind of the next thing that's going to happen in a case sequence based on everything that happened before it. And these are using the same kind of transformer models that are being used in language models. And so what you can do once you have that is you can then do things like find outliers, right? So if this, the bond was very different from what the model predicted for these sets of cases, then maybe those are ones that need more transparency or oversight to understand what's different about this case or, what's causing these differences. The second reason these foundational models are useful is that you can start answering more causal questions about the data, right? So if I changed variable X to variable Y, how would that affect the outcomes? A second thing we're working on is just visualization. So once you have all this data, and you're trying to provide more transparency into it. What sorts of visualizations help people actually understand, to identify these outliers, to identify trends in the data? And this picture is not one that does that, but this picture is one that just shows you kind of just, this is each row here is a different case, and we have indicators kind of showing where that case is in its trajectory. Okay, but more into modern day like LLM kind of stuff. The third avenue we're exploring here is this notion of chatting with a case, and I think this is a good example because I think you'll see a lot of startups around this idea of I've got kind of complex data types, right? So here I have these court observations, I have court dockets, maybe other things, and I want to be able to intelligently kind of talk to the data, right? So I don't want to have to do a SQL query to find things. I just want to be able to say like, okay, based on what you see in this case, like, tell me what you think the next 3 proceedings are going to be like. Or is this case similar or different to other cases, like it in the past? And if so, how? Right. So, to me, one of the great powers of this kind of ChatGPT revolution is that now we can converse in human language with complex data. And so that's one example that we're exploring here. Okay, on to the second example. So the second example came through a partnership with a group called Ion Surveillance. Great group. They've been looking into all this facial recognition that the city has been doing. There's been a lot of back and forth in that you may have read in the news. But one thing they found was, if you want to learn like what is the city or any government doing with particular data or methods, you file a public records request, right? But it turns out to file a public records request, you actually need a lot of detailed data. You can't just say, tell me every time the city has done something involved facial recognition. You have to say, can you please go find for me the report submitted to City Council on January 20th, right? But I don't know about you, but not a lot of folks have time to sit around and sit in City Council meetings all day to see what's going on. Separately, of course, many organizations, right, nonprofits, journalists, government watchdog groups, struggle keeping up with kind of city business, right? So we have this big, budget shortfall in the city, and you might say, well, what caused that, and how, and was it discussed, and who discussed it when? So kind of starting with Ion Surveillance, and continuing on with collaborations with Tulane, we have the system where you can again interact intelligently with complex data. The complex data here being videos from city council meetings, which have to be transcribed so that you can then ask questions like, what is New Orleans doing about homelessness? And you get back not only a summary, but also links to specific second markers, right, in the videos themselves, so you can go back to the source material. Again, thinking about going from MVP to real products, right? This issue of hallucination, confabulation is one that comes up over and over again, and being able to ground the output of your system in kind of verifiable, trusted pieces of information, I think is going to be critical to getting buy-in to any of this sort of stuff. And this is just one simple example of how to do that, right? Is, well, let me link to the actual source that's being used here. Okay, so this is sometimes called a RAG system, retrieval augmented generation. Again, very popular use case out there where you suck in as much data as you can, and this provide a nice little querying interface where you can ask complex questions and get useful, actionable summaries from them. I'll go through this a little quickly. Again, getting back to the participatory design aspect of this, when we first started this, we had some community outreach meetings and had them use kind of beta versions of the app. And one thing we found pretty quickly is that when you look at the responses you're getting from the system, they tend to be very favorable to the city council members themselves. So if you say, what is city council doing about X? The system often says, oh, they're doing wonderful things. They're solving all these problems. And of course, oftentimes there are, but part of the issue here is there's this bias in the way that the system summarizes this data, because most of the words it's being used that are being ingested in the system come from the mouths of the city council members themselves. And so, of course, the summaries you're going to get back are going to be colored by that perspective, right? And so that's one, people think you just throw everything into the RAG and like you get perfect responses. But data, right? It's always what is the data and what perspective is that data bringing to the system. So I'm going to kind of, just point out again, you can do this. We have several different versions of this app where you can get kind of summaries and again, link to the actual minute marker, which I think is cool because sometimes you'll get the actual PowerPoint slide that like summarizes the question you're asking about. So I think this is kind of part of a broader area, right, of like interacting with city data via language models. And you'll see there's a lot of interesting startups out there and other companies trying to do this. But I think this is a really ripe area because there's just a lot of really important information hidden in obscure, kind of government websites and places that, with the right infrastructure, suddenly I think there's a lot more opportunity for transparency and accountability in government. All right, my third and final example is in the health space. And this is a collaborative project with folks in the med school and public health at UL Lafayette, as well as DePaul Community Health Centers. So the goal here is, and even for folks with kind of limited interactions with the health system, if you're like me, whenever you leave the doctor's office and you get that kind of little piece of paper that says, here's the things you're supposed to do. I read it like 10 times and I'm not really sure what it's telling me to do. And of course, that only gets more complex the more complex your health situation is. So the goal here is to partner with different organizations to provide a chatbot that can help folks with diabetes understand kind of what are their healthcare options, what impact do different choices have on their future health outcomes, that kind of thing. And the system we're in the middle of building, called the Conversational Health Agent, that's just an LLM, is going to have access to three things. One, the health records of the individual. And already that should raise flags like, oh my gosh, how is this going to happen in a private, secure way, right? The second thing it's going to have is educational literature. So like the actual documents that traditionally people will give to patients to help them work through their healthcare. And then the third thing is, these risk models, right? So our people have been building risk models for many things for a long time now. For example, you can tell me your cholesterol, your blood pressure, your glucose levels, and kind of forecast, over the next 10 years, what's your risk of a cardiovascular event, for example, right? So there's dozens and thousands of these types of models, but they don't, how do they get used, is still a little questionable right now, right? And part of the issue is they're not super personalized. And moreover, it's hard to ask like what if questions. Well, what if I go on this diet and my blood pressure changes by X? What impact will that actually have? So one of the other cool things about these kind of modern agents, not only sucking in all kind of complex data, but also this tool usage that Nick was referring to, right? So it's not just generating tokens, but it's generating tokens that lead it to run other methods and get outputs, right? So here, part of the thing we're building is that the patient can ask questions like, how will reducing my blood pressure change life expectancy? And what the model is going to do is actually update their blood pressure by some percentage, run this risk engine, get back new values, and then communicate them in some useful, digestible way to the patient, right? So now we're not only just accessing data, but we're actually running other predictive models through the LLM in a way that the output can be communicated back to the end user. And so this combines ideas both from this retrieval augmented generation, which I talked about in the other projects, as well as these kind of agentic things of being able to call these different tools. And so one way to think about it is if you've heard of explainable AI, the basic idea is, okay, great, you have some predictive model, but explain to me why it made this prediction, right? So I think LLMs provide a powerful kind of interface to communicate kind of the output of one of these predictive models with, in an explainable way so that the human can understand actually what's happening. Okay, same deal, right? Participatory design. And so we're working with DePaul, with the clinics here at Tulane, with the Community Advisory Board, to kind of get feedback all along the process so we understand, well, what are the things people want out of the system? What kind of data is kind of inbounds and out of bounds? Safety checks, right? So this is going to be huge. Any application where now you're talking about, private medical data, private information, um, there's a whole, kind of industry dedicated to kind of oversight of these LLM models, right? And so this can mean a few things. Like one is, making sure it's educational only and not like saying, oh, you should go take this drug, right? Leave that to the doctor. So it's kind of what's inbounds and out of bounds as far as the output. Graded generations, I alluded to earlier, like being able to cite documents used for answers. Content filters, right? So you can use both kind of traditional approaches as well as other LLMs, right, to monitor the output of this thing and say, oh, wait a minute, you can't output this thing. You have to kind of refuse to answer that. Readability, right? Being able to tailor this to a particular patient so that it's kind of at their education level is one simple thing to do. And then finally, if you think about from a traditional software engineering perspective, LLMs are a nightmare, right? Because they're very hard to test. You can't write a little test that says, if X, then Y. So instead, we do this kind of empirical approach where you kind of shoot a barrage of queries at the system and test them for unsafe responses. So you can tell every time I change something about the system, I improved accuracy, but did I increase the risk of kind of bad responses? Okay, so I'll kind of stop there. So those are kind of three examples of different areas where, we're using AI kind of out in the community to try to solve problems. And I guess the kind of the takeaways here from a startup perspective, right? One, yeah, build your MVPs, use all the low code, no code methods. But two, really think hard, especially about these last things about, well, how am I going to actually evaluate this thing? How am I going to put guardrails on it to make sure the outputs are kind of in bounds? And then three, really thinking through, well, who are the stakeholders involved in this system I'm trying to build? And am I really involving them in a deep way, kind of throughout the design process, to ensure that the final product is actually something that will be kind of useful for everybody involved. All right, I'm going to stop there, and we can see if there's any questions, I guess.
Feel free to drop your questions in the chat or just shout them out loud. For our presenters, we often encounter companies and startups that have a great idea and are planning to use, they'll say, we're going to use AI to manage X. We're going to use AI to manage these things. Are there any specific industries or situations where someone should be referring to external help instead of leaning on AI? I know that may be kind of a general question, but yeah. So the premise is, I want to start a water bottle company, and I know about hydration, but I don't know much about the other parts of it. Like, what advice would you give me if I said that I'm just going to AI the rest of it?
I wouldn't have an AI your regulatory compliance or your manufacturing contracts and things like that. I think the way that I think about what especially these like AI chatbots are good at is they're basically good at performing C-level work. They're very good at that. And so I think I've seen a lot of folks, help generate early marketing plans, things like that. Like, generate some like light ad copy or something like that. Like that all works. It works fine. You're gonna want to make sure it doesn't suck. But I think for the things that matter, the things that are like, oh, our regulatory compliance, oh, our manufacturing, it's you got to be a bit more careful about what you're using these things for. And that's more of how are you using them? How are you using the chatbot to help you build a startup type question? I don't know, Aaron, if you had any more thoughts.
Yeah, I mean, I say there's a difference between like getting information versus making judgments, right? Like you could use, just like you use Wikipedia, right? You could use ChatGPT or whatever to understand like, okay, here's the scope of kind of decision points here. And that gives you kind of a baseline so that when you go to talk to an expert now, you already know the jargon, you already know kind of the background, so you can ask more useful questions to them. But yeah, but things that require judgment, 100%, like you want to consult an expert there. But I think AI can help you find who is the right title to talk to, for this kind of question.
Yeah, and I think in terms of, and I've done some panels with some other folks who I think are a bit more expert in, I think there's a lot of opportunity to help scale startups. Like if you want to, you can have companies help with backend, help with customer service, things like that. Like you can offload. I think you can use some of these off-the-shelf AI tools to help do things like that. And my joke I've been making all day is, I'm back in academia because I'm not good at the business part. And I think there's definitely a lot of tools and stuff on the back end of the business side that I think can really help. But again, I think you want to be very judicious with how you use those things, right? Like I've definitely have talked to people who have turned their entire marketing over to AI, and it's they're just like, oh, just write me the Instagram post and then post everything and da da da. And it sometimes it works and sometimes it doesn't. So you got to really. I think the guiding light is it can do pretty decent BC average work. And are you okay with that part of your business or that part of your infrastructure or that part of whatever operating at that level, or is that like a core part of your value? Or is it a core part of your value creation? And in which case you might want to actually, get somebody who knows what they're doing.
Okay.
I'd say that even, I don't know, Aaron, what's your opinion? I'm going to start a fight. How do you feel about that for some of these like vibe coding tools? Like, are we still at like kind of the BC, mid-range student? I had my own experience with some undergrads, just vibing their way through some projects that turned out really not to work for the most part.
Again, yeah, I think for MVP, they're great, right? But now you're like, oh, let's scale it, let's secure it, let's test it. That's where you still need that kind of that human judgment, I think. So given that user judging, this tech becomes more user friendly. Okay, so Duan has a question in the chat. You build your user engagement involves more user friendly to date your tool.
Yeah, this was if I had the answer to that one, I might actually have a successful business. I think it's tough, right? You see this in legacy application. I think you see this in legacy applications and you see this in startup space as well. It's like, if you're still running, and you see this with Apple, right? This is why Apple's partnering with Gemini. Like even at the top of the stack here, is because Siri was starting to be seen as a legacy tool, right? It couldn't respond to certain things. It couldn't keep up with what folks were expecting. And so I think you have this across the board, right? Like if you've got your phone tree as like a phone tree system from 1977, and it's like, please press 2, like that's going to impact your customers in some way. So it's a really hard question. And I don't know how we do it on the academic side too. Like Aaron and I are both trying to build new courses and drive them at the same time. And even the course that he sort of put up that he was working on this year, like it's a crazy space. Stuff is moving really fast.
Yeah, I mean, part of that's kind of a software engineering question, right? Software engineering, you're always trying to like design things in such a way that they're loosely coupled. So if you want to swap out, technology A for technology B, you can do so with kind of minimal changes to the rest of your code base. I mean, I think the same thing applies more at the systems level. If you're building some application or some kind of service, is always thinking about like how tightly coupled is decision A and decision B, and can I make them less tightly coupled, right? So that it's easier to adapt and swap things out as suddenly a new capability arises. You don't have to kind of start from scratch.
Thank you for that. It's something that I'm constantly trying to keep up.
There is no keeping up. I think it's kind of zen about it. Like just let it wash over you.
Yeah.
Comforting to hear from you all. Thank you.
Thank you. All right. So we are coming up. Also, hi, Duan. Very good to see you. Very good to see you. We are coming up on time. So if you wouldn't mind just going to that very last kind of closing slide, I will give us the exit.
Sounds good. Grace, quickly, Aaron put the mailing list and the website in the chat, and that's probably the best way to get started. We send out announcements for our talks and things like that. Always happy to chat on our side. Oh no, I closed the file. Sorry, guys.
All right. Oh, the slide right before this one, actually.
Oh, sorry.
Yes. So thank you again so much to our presenters. I always like to go over a few of my nuggets. Thank you for the brief AI history and overview and the examples of everything from AI monitoring, criminal court, an overview of data integration, retrieval augmented generation. And one of my nuggets was you need to ground the output of your system into specific source material. So everything that you are getting from your LLM or your AI, you should be able to link directly to some source material, but be careful. Be careful of the bias in responses. We saw the example of city council, like the AI was pulling what the city council members were saying about themselves. So definitely be cognizant of that. We learned a little bit about work in the health space, and just food for thought that AI should not be the first thing you use for regulatory compliance or manufacturing contracts. Expect C-level work, and it is really good for getting information that is going to teach you the jargon, the background about, and the scope of your decision points, but not for things that require judgment, to reiterate. So thank you again so much for joining us. We hope to see you at some of our future events. We have an in-person open season pitch competition on January 28th. That is next week. We are having another webinar on February 4th covering sales strategies for startups. And then once again, in person, we're going to have a Tulane Innovation Day in conjunction with the New Orleans Entrepreneur Week. So thank you all once again for joining us. We hope to see you at future webinars. And if you wouldn't mind going to that very last slide, you can scan these QR codes for support with your ideas. I'm one of our ad hoc mentoring facilitators, or just stay tapped in with us through our LinkedIn and our newsletter. So thank you again. Hope everyone has a wonderful rest of your day and stay warm this weekend. Goodbye.
All right. Thanks, everybody.
Thanks, everybody.